Hello boys and girls, welcome to Mrs. Sandu's Math Movies. This is for Algebra 1, Lesson 6-6, Parallel and Perpendicular Lines. Our objectives are to determine whether lines are parallel and determine whether lines are perpendicular. Okay, so first of all, let's just look at concepts and terms or vocabulary. Non-vertical lines are parallel if they have the same slope but different y-intercepts. Okay, sorry, that ran off the page there just a bit. So non-vertical lines are parallel if they have the same slope and different y-intercepts. Any two vertical lines are parallel. The equations y equals 2/3 x plus 1 and y equals 2/3 x minus 3 have the same slope of 2/3 and different y-intercepts. The graphs of these two equations are parallel. So if it's in slope-intercept form, if they are in slope-intercept form, the equations can be determined whether or not they're parallel rather quickly by checking their slope and then checking that they have different y-intercepts. Slopes of perpendicular lines. Two lines are perpendicular if the products of their slope is -1. A vertical and a horizontal line are also perpendicular. So here's an example. The slope of y equals -1/4 x minus 1 is negative 1/4, excuse me. The slope of y equals 4x plus 2 is 4. Since -1 times 4 is -1, the graphs are perpendicular. So basically we can also say that the slopes of perpendicular lines are negative reciprocals of each other because their product is going to be -1. Okay, parallel lines are defined as lines in the same plane that never intersect. Perpendicular lines are lines that intersect and form right angles. The product of a number and its negative reciprocal is -1, okay? And that's how we can tell that lines are perpendicular if we know their slopes. All right, writing equations of parallel lines. Write an equation for a line that contains -2, 3 and is parallel to y equals 5/2 x minus 4. Identify the slope of the given line. It's 5/2. Write an equation of the line through -2, 3 using slope-intercept form. So in the end, we want it in slope-intercept form. Because we have the slope and a point, though, we're going to use point-slope to get there. Okay, so sometimes what you want in the end isn't where you're going to start, so you want to be careful with that. Okay, so y minus y sub 1 equals m times the quantity x minus x sub 1. We're going to substitute -2, 3 for x sub 1 and y sub 1, and 5/2 for m, our slope. So this is going to be y minus 3 equals 5/2 times the quantity x minus -2. So y minus 3 equals 5/2 x minus 5/2 times -2. So y equals 3. Oh, I'm sorry, y minus 3 equals 5/2 x plus 5. So y equals 5/2 x plus 8, because I'm going to add 3 to each side. So just kind of to backtrack a little bit, I distributed here, multiplying 5/2 times x, and then subtracting 5/2 times -2. In the end, what happens here is that I end up with positive 5. So I get y minus 3 equals 5/2 x plus 5. We're going to add 3 to each side and simplify. So my equation is y equals 5/2 x plus 8, where my y-intercept is going to be 8. Next example, writing equations for perpendicular lines. The line in the graph represents the street in front of a house. Okay, so we see that marked here. The sidewalk from the front door is perpendicular to the street. Write an equation representing the sidewalk. Okay, so first of all, let's scope out. We see our x-axis here, our y-axis here. The sidewalk has, let's see, the sidewalk has the point, what is this, 0, -3. And we can go from there. So first of all, let's find the slope of the street, excuse me. So my points on the street would be 0, 2, and 3, 0. Okay, any two random points are fine, but those are the points that I see most easily, so that's what I'm going to use. Actually, those are my x and y intercepts. So that's going to give me 0,